All right. Get folks in here. All right, hello everybody. Let me see. They're still coming. Good, people still coming in.
You know, the chat and the Q&A, so I'm not sure which one.
All right, Eric, is it looking good over there?
We're looking good.
All right,
The box just pops up.
okie dokie. And Bill, are you good? Dan, are you good?
We're good.
All right, here we go. So welcome everyone. Hello. Welcome to AMS Weather Band's latest webinar, GOES-18, NOAA's newest Eyes on the West, with Dan Lindsey and moderated by Bill Line. Now, before we begin, folks, I would like to address some of the ground rules for our webinar today. There's one thing I want to do before that, though. If you could please be so kind as to change your Zoom name on the Zoom that you're using to view us now. There was a little snafu with that. So if you would be so kind as to change it to your name so that we know who's addressing us with questions, that would be great. Next, if you have a question during the webinar, please put them in the Q&A button that you'll see at the bottom of your Zoom screen. You're probably familiar with the chat button at the bottom. Well, to the left of that, there should be a chat or a Q&A option button. And any questions that you have for Dan or for Bill, please put it in that Q&A option. All right. Chat option, if you choose to put something in there, we will not look at it. It will not be considered. So keep that in mind. Also, folks, kindly keep your camera off. And we will have some specific time for questions from the audience after the interview. All righty. So first, I would like to introduce today's moderator. Thank you, Bill, for joining us today. Ladies and gentlemen, Bill Line is a physical scientist with a NESDIS, STAR Regional and Mesoscale Meteorology branch in Fort Collins, Colorado. Bill is the STAR Imagery Team Lead and is involved with GOES and JPSS Imagery validation, product development, user engagement, and research. So, Bill, the floor is yours. Thank you.
Thank you for that introduction, Gideon, and thank you everyone for joining both in person and virtually today. I have the pleasure of introducing our speaker today, Dr. Dan Lindsey. Dan has been with NOAA since 2004 and currently serves as the GOES Program Scientist. He received an undergraduate degree in mathematics from the University of Georgia and master's and PhD degrees in atmospheric science from Colorado State University. Dan's areas of expertise include satellite remote sensing, mesoscale meteorology, and cloud physics. Dan, we are extremely excited to hear you speak today about GOES-18. The floor is yours.
All right. Thanks a lot, Bill. Thanks, Gideon. First of all, want to double check you guys can hear me?
Yes, we can.
Okay, great. Good afternoon, everybody. Thank you for joining us. I think some of you may be joining from the satellite conference in Madison. I'm not 100% sure, but if so, I'm glad you were able to. I will say that if you happen to catch the session yesterday morning from Pam Sullivan and myself and others, this will be some of the repeated material. So apologies in advance. But the good part here is I think we'll have time for questions and answers at the end, and we didn't really have time for that yesterday. So as Bill mentioned, I'm going to be talking to you about NOAA's newest geostationary satellite, GOES-18. I want to start with just a quick review about the geostationary program. As is many things in the government, GOES is an acronym, stands for Geostationary Operational Environmental Satellites. And this graphic shows the history. The GOES program goes all the way back to 1975. We launched GOES-1. It was the very first GOES. And then since then, every few years, we have been launching new satellites. And with every sort of increment, every 3 or 4, there's an improvement in the technology. And this shows the way that works. GOES-1 and 3 had they were all sort of clones of each other, 4 through 7, et cetera, et cetera. And then you may remember back in 2016, we launched the current generation of GOES. We call it the GOES-R series, but it's really GOES-16, 17, now GOES-18, and then GOES-U is the 4th, which I'll talk about later. And then at the end of the presentation, I am going to mention GeoExo. That's going to be the next future generation of geostationary satellites launching in the 2030s, and it's something we're really excited about right now. Okay, I'm going to get out of PowerPoint and try to show this about a 1.5-minute video of the GOES-18 launch. This happened from Cape Canaveral, Florida on March 1st earlier this year. Spectacular launch. I'm going to play the video now.
Status check received. Terminal count. TCQ. Go. Operation support. Go. Go. Umbilicals. Go. ECS. Go. Redline monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Use coordinator. Clear to proceed. Launch director. You have permission to launch. Proceeding with the count. Go Atlas. Go Centaur. Go GOES team.
Liftoff of NOAA's GOES-18, our newest weather sentinel in the sky to help keep us safe here on the ground.
Gen 63 chamber pressures look nominal. Vehicle's begun a pitch out roll maneuver. Tower clear. RD-188 engine parameters look good. SOB jettison. And we have indication of successful spacecraft separation of the GOES-T spacecraft.
All right, so thanks to ULA for that video. And I'm going to go back to the PowerPoint now. 1 second. Okay, so let's get into it. First, before talking about GOES-18, I want to say a few words about the other operational satellites that we have. In the east position, this was the first one that we launched back in 2016. The GOES-R became GOES-16. It has been the operational GOES East satellite since 18 December 2017. And this beautiful picture that you see here shows its domain centered over 75 west longitude at the equator. And you can see the hemisphere that it covers. It's really the primary satellite for much of the continental US and of course the Atlantic to keep an eye on those hurricanes as they come in. The primary Earth observing instruments on the GOES series is the Advanced Baseline Imager, the ABI. I'll be saying lots about that today, as well as the Geostationary Lightning Mapper, the GLM. Let's see. So this gives a better indication of the breadth of things that the ABI and the GLM and all of the space weather instruments are able to measure. This is not everything, but it's sort of the highlights, I would say. Tropical cyclones, of course, hurricanes, severe storms. We're able to take a look at those storms, oftentimes before they even show up on radar, to give forecasters a heads up on where the storms are forming. Atmospheric winds, we can track the clouds, feed that information into the models, improving the forecasts. Wildfires is a major application. I'll be talking more about that later. Volcanic ash as well. I mentioned GLM, where for the first time we're able to track lightning in real time and with a constant view from geostationary orbit. And then lastly, we do have some space weather instruments, and those are pretty important, and I'll be saying a little bit more about those as well. Okay, so one of the first questions we always get with talking about GOES-18 is what's new? How is this different from the other GOES satellites? And the short answer is it's really not that much different. It really does have pretty much the same set of instruments. There were a few changes to some of the instruments. For one example is the ABI itself was redesigned using an ammonia-based cooling system. Some of you may remember the loop heat pipe anomaly that we had with the GOES-17 ABI. We switched out the cooling systems with the GOES-18 ABI in order to fix that problem. However, it's essentially the same instrument otherwise. And then the other one is the magnetometer. This picture on the right, this is actually not from GOES-18 itself. This is sort of a sketch from one of our earlier satellites to show you where the magnetometers themselves lie. They lie on this big boom that sort of sticks out from the side of the satellite. But we replaced the other magnetometers with ones built at Goddard, NASA Goddard Space Flight Center, and we call it the Goddard magnetometer, or the GMAG. And I'll be showing some data from that GMAG a little bit later as well. So here is the very first animation that was released from GOES-18. We did launch to the checkout longitude of 89.5. That's the center of this view here as you see the sun go around. The longitude of roughly Chicago. And this is the typical place where we've done all of our checkouts, our testing and everything with the GOES satellites. And this particular animation comes from 10 May of 2022. Shortly after this animation was taken, we did move the satellite from 89.5 out to a west location. And so in some of the subsequent examples I'm going to be showing you, it will be from that west location. And I'll talk later about why. The next set of movies, however, is from the test location when we were at 89.5. We were sort of taking a look at lots of different things to make sure everything looked good. These images that I'm showing now are from the Advanced Baseline Imager. You can see the beautiful, we call it geocolor imagery, which is an approximation to true color. This is an algorithm which was developed at CIRA, and it really gives us unbelievable resolution. At this particular example is upscaled to the 500-meter resolution. So you can literally see things like the Miami metropolitan area compared to some of the vegetated areas around it. Also in this, from a meteorological perspective, you get a really nice view of that sea breeze that's coming in on both coasts in Florida. And we do get convective initiation or storms forming there on the southern end in the Everglades area there at the end. The last thing to point out is I see some smoke. You see that sort of grayish color that's occurring here south of Lake Okeechobee due to some wildfires happening in South Florida. So really just from one simple animation, you can see all sorts of meteorologically interesting things. Here's another look, same day, further south. You may recognize this landmass as being the Yucatan Peninsula of Mexico. And this just shows some really cool looking cloud streets that are forming in the strong southeast low level flow. It looks like it's pretty stable this day in that very few storms are actually forming. There must be a nice capping inversion in place, but we do start to see maybe some hints of some convective initiation there on the northern Yucatan near sunset. Here's a look. It's often forgotten by us in the continental US that we do scan the southern hemisphere every 10 minutes along with our full disk. And this is an example out of Argentina and Chile, looking sort of panning to the south and looking at the evolution of some stratocumulus clouds and some fog that have come inland there west of the Andes Mountains. You can see the Andes are forming a barrier, keeping those clouds to the west, and you can see snow forming there, or existing rather, on the tops of the Andes Mountains. So just beautiful imagery. Our partners in South America do use this data quite a bit. And then here's a quick look at our 1 minute sectors. We're able to scan mesoscale sectors every 1 minute. We call these our mesoscale or mesodomains. This is at 500-meter resolution, and with every minute you can see really unbelievable details of what's happening in these storms and in these clouds as they form. You see the bubbling nature on the tops of the storms, excuse me, due to the active convection, and you can see the clouds, the boundary here, as new storms are forming on the southwestern flank of this convective system. These particular storms, I believe, were in Texas back on the 5th of May, and they did produce some severe wind gusts and hail. I mentioned earlier one of our primary applications is fire detection. And so here's an example of the geocolor product. Once again, this was on that same day from the 5th of May. And we're not looking at the hotspots themselves here, but we are looking at smoke. And the geocolor product is very good at distinguishing smoke, which is the sort of grayer color, from the meteorological clouds in the snow, which appear more white. And so when you combine this the visible imagery like this, where you get the smoke with the thermal detections from the infrared, you can see both at the same time, and I'll show an example of that a little bit later. I did mention that GOES-18 is now out west, looking over the western domain. I'll show examples of that, but one of its primary goals in the west is to detect hotspots for fires. We all know that there's increasing wildfires every year out west, and it's very critical for us to be able to pinpoint those as quickly as possible with our GOES satellites. And here's a look at all 16 bands at the same time from the GOES-18 data, just showing you that we have really very high quality data at this early stage during the checkout time, and thanks to SIMS for this animation. Moving on, so now we have moved out to 136.8 west in this animation. This was from, this particular example is from the end of June. It was very hot and dry in Alaska in the month of June, and we did have quite a few wildfires that formed. This is an example of that sort of overlay I mentioned earlier, where you see the red areas, that's the hotspots themselves from the thermal detections from the ABI. And then we've overlaid that geocolor product so you can pick out the smoke. So firefighters are able to take a look at this imagery, or the weather service or emergency managers, really anybody that's interested can take a look at this, keep track of where the hotspots are, where the smoke is going. And it can be really important in the operations for the fires themselves to let aircraft know, is there a sufficient clearing in the smoke to allow them to fly in and do their suppression activities. Another thing to point out is check out how good the resolution is this far north. This is not something we were able to do with our previous satellites with any clarity whatsoever. It was really blurry, but due to the improved resolution with the ABI, we can see Alaska really well, even though it's north of, say, 55 or 60 degrees north latitude. Since we are in the Pacific, hurricanes don't get quite as much press as they do in the Atlantic, but we absolutely do have very strong hurricanes in the East Pacific. This is an example of just last month, a Hurricane Darby that occurred on the 13th of July. This is 1 minute data. And those of you, if there's any weather service people on, you may recognize that this is a screen capture from the AWIPS software system. You can really look down into the eye and see these mesovortices that are spinning there within the hurricanes, thanks to the high resolution and the rapid updates of every 1 minute. Okay, let's move on to different instruments. We're now going to switch to the geostationary lightning mapper, or the GLM. What's plotted on here is really 3 different data sets. The first in the background, the clouds, that's just ABI visible data like we've been looking at before. The colors is data from the GLM itself. This is from the geostationary lightning mapper flash extent density product. And that's overlaid, and that tells you really where the active lightning is occurring within these convective clouds. And then the last thing that's overlaid is pretty easy to pick out, are these little plane-shaped features, is just tracking active flights in this example. And what's really neat is you can actually see the planes diverting themselves around these storms, like this convective complex here around Hastings, Nebraska. The planes are basically going right around it and going into wherever they were before. So lightning data is used along with other data by the pilots and by the FAA and by the Weather Service to help keep the planes out of harm's way and away from these dangerous storms. I'd like to shout out to Joseph Patton and Scott Rudlowski. Thank you so much for this amazing animation from GLM. Okay, let's move on a little bit to our space weather instruments. This is something that may be new to a lot of you, especially you meteorologists, since this is more of a space weather, maybe a solar physics thing, but it is really important. The first instrument is called the SEIS instrument, and this is actually a series of smaller sub-instruments on SEIS that collects particles from up at geostationary orbit. This example comes from late April of 2022. The MPS high instrument is shown in all 3 plots. Notice that the vertical scale here is a log scale. So really any little change in these lines is a pretty big difference. And we're looking at a time series over multiple days in late April. And you see these various bumps that occur in all of these. These are fluxes. And what we're seeing here are radiation belt disturbances that are associated with the geomagnetic storm. We are approaching the solar maximum. It's going to happen in a few years, expected in the mid-2020s. And as that approaches, we get more and more of these solar storms, flares, coronal mass ejections, and instruments like SEIS are really important to monitor those and really know what's coming our way toward the Earth. Here's another one of our space weather instruments. This is the magnetometer. This is the one I mentioned earlier that we switched out and put in a new one built at the Goddard Space Flight Center. And again, we're looking at a time series. This is just 1 day in April, the 27th of April. The top panel shows the total magnetic field, and then the middle panel shows that it has been where it has been filtered in order to highlight something called plasma waves. And there's many applications of the GMAG, but the general idea is to keep track of the magnetic field surrounding the Earth out at 36,000 kilometers where geostationary orbit resides. And then another one of our space weather instruments is known as the Extreme Ultraviolet and X-ray Irradiance Sensor, or EXIS. This example is from 5 of July. The XRS is one of the subcomponents on the top, and then the other 3 plots down below are showing the EUVS data. And what the peaks that we see here, once again, there's a log scale. We see a couple of peaks in the top plot, and these are indications of moderate solar flares. And in the bottom plot, we really just see the second peak. And that's the reason we see different things at different spectral regions is because each of these spectral bands is essentially looking at a different part of the sun, with the corona and extremely hot corona in the top, and then the transition region and the chromosphere, the sort of less hot areas toward the bottom. And then the last one I want to talk about is something called SUVI, the Solar Ultraviolet Imager. This is essentially taking pictures of the sun in the ultraviolet. I mentioned earlier the 11-year solar activity. In this example, you can see this coronal mass ejection down in the lower right part of the image, a really incredible imagery there as one of these things moves off. So really what's happening is forecasters from the Space Weather Prediction Center, or SWPC, in Boulder, Colorado, are taking a look at this data along with other data to provide warnings for solar storms. Solar storms can, in the most extreme form, cause effects on Earth, things like electrical blackouts. So it's really important to keep track of these on Earth. Okay, I'm going to go back to the ABI now and just talk a little bit more generally about the things that we expect to see with GOES-18 out west. I've already mentioned wildfires. I tossed in this example. This is from GOES-16, way back in 2017 when it was in the checkout location. But I wanted to point out Western Montana. We had a really dry summer in Montana in the summer of 2017, and you can see these hot spots and the smoke and these pyrocumulus clouds actually forming on the tops of these storms. Really incredible imagery. Okay, moving on to another example. This was actually just a few weeks ago, really the end of June. This was the McKinney fire, sorry, in Northern California from 30 June. This is from GOES-17. It was before we were really actively collecting, sending out data really from GOES-18. And you can see just incredible 1-minute imagery. It's easy to distinguish the brown smoke from the white clouds. And there is some pyro-CB or pyrocumulonimbus storms forming on the tops of that storm. On the tops of the fire, rather, sorry. Okay, volcanic eruptions. I'm going to cheat a little bit here. This is actually not from any of our GOES satellites. This is an example from the Himawari 8 satellite, which is run by our partners JMA out in the West Pacific. They are nice enough to share their data with NOAA, and our weather service uses this all the time, as well as our volcanic ash advisory centers. They use the data. And this is just a really picturesque eruption that occurred on an island south of Kamchatka, which is in the Northwestern Pacific, several years back in 2019. And you can easily see that brown volcanic ash and brown emissions there over the tops of those low, very bright white clouds. And then one other example from the Himawari satellite, I believe this was courtesy of Curtis Seaman from Sierra. This example shows the ash RGB, and you can see the volcano happening there on the southern tip of Kamchatka. What I think is really cool in this example are these linear features that you can see across the sort of streaks along here. Those are actually contrails from airplanes. This is a very common flight path of any flight coming from North America going to East Asia. And what's cool is you can, if you watch really closely, I hope you can see this, you can actually see the deviation of these contrails. And what's happening is that the pilots are getting word of this volcanic ash plume and they're being diverted. And that causes sort of this kink in their contrail as they move around to steer clear of that. Volcanic ash is very dangerous for airplanes and their engines. So it's important for us to monitor it and let them know, and so that they can keep the plane safe. Okay, I want to talk a little bit more about GOES-18. This is the nighttime portion of the GeoColor product from, let's see, this was the 24th of July, just a couple weeks ago. And you may notice this sort of flickering north-south oriented feature that looked a little bit like a barcode. This is something that we're seeing in band 7, which is the 3.9 micrometer band. And it's due to a slight increase in noise in the band compared to what we saw with GOES-16 and GOES-17. So it's only a tiny increase, and the reason it's tiny, and that means that we only see it in some of our multispectral products. And what I mean by that is, if you take the difference between band 7 and say one of our window IR bands, it sort of enhances everything, including if there's any noise at all. Now, from a products perspective, this really doesn't affect anything. The products, the level 2 products, things like our cloud detections, our fire detections, There's negligible difference, really no effect at all. The only thing is from our eyes, as we look at this and we say, oh, there's sort of this flickering. However, if your job is to detect or to look at clouds and find where the low clouds are, it's pretty easy to do that. That's still just the blue areas here. So even though this is meeting specifications with the instrument, we are going to take a look with our partners and see if there's any mitigations we can do to sort of improve that barcode artifact. Okay, the other thing that we're doing as a mitigation for GOES-17 is we started something on August 1st called Interleave. And those of you who have an operational data feed of GOES West data may have noticed that the data switched from GOES-17 ABI to GOES-18 ABI at 17Z on August 1st. And the reason that we're doing that is due to this loop heat pipe anomaly, which is something that we've been dealing with GOES-17 over the last few years. And the chart here shows an indicator. The blue line shows a prediction of the daily peak long wave detector temps from the GOES-17 ABI. And the point here is to show that it's seasonal. We have 4 peaks. They occur before and after each equinox. So basically February, April, August, and then again in mid-October. Those are the 4 peaks. And that's when we lose the most of our GOES-17 imagery due to saturation. And so the current, when we just happen to be right here in early August, it is during one of these high areas, one of these warm areas. And so the Weather Service asked us if we could basically replace the GOES-17 data feed with GOES-18 during this period as a mitigation for that, those missing images from GOES-17. So those of you with an operational data feed, pull up GOES West, you will be seeing GOES-18 ABI right now. Now on September 6th, we sort of get past that. We enter the eclipse period, things cool off, GOES-17 data gets a lot better. And so we're going to switch back to the GOES-17 during that period, and then once again go to a second interleaf period in mid-October. So thanks to Matt Siebold and Liz Klein for this plot. I'm going to go to the next slide and show an example of what happened when we entered interleave. You can see in this loop, the beginning of the loop is from August 1st before 17Z, and then later on it switches to after 17Z. And you can see this seamless transition from GOES-17 to GOES-18. It goes from being sort of degraded with the horizontal stripes to completely clean. And that was due to this interleaf process where we basically replaced the data flow of 17 to 18. And here's just one more example of that. You can see the horizontal stripes, the noisy data before, and then after we switch to GOES-18, it goes away completely, very clean imagery. So we're really excited about this capability, and we'd like to thank everybody who contributed to getting it set up. Here's one more chart that shows the planning for the details. For those of you online, if you're really interested in this, I suggest taking a screen capture, and you can also find this information on the OSPO website, NESDIS OSPO website. But right now you can see we're in this interleaf period where we're sending out GOES-18 data. And then on September 6th, we're going to go back to GOES-17 as the operational data feed. And then on October the 13th, for about a month, we're going to go back to GOES-18 data one more time. And then finally, in January, the plan is to switch the operational data feed permanently to GOES-18, and that will become GOES-18, then will become the operational GOES West. We always get the question, what do we do with GOES-17 at that time? I'll answer that now. We will then, in mid-January, drift it over to 105 West, which is the storage location of GOES-17, and it will be there as our on-orbit spare. So what that means is if there's any problems with GOES-16 or GOES-18, we can basically just turn on GOES-17, begin scanning, and it'll serve as the operational backup. And then this just, I'm going to skip over this due to the shortage of time, but this just sort of shows where the locations are at various times, or where the satellites are at various times. Okay, a couple words about GOES-U. I mentioned this is the third, GOES-T and GOES-18 is the third satellite. GOES-U will be the fourth satellite. It's planned for launch in April of 2024. It's going to have essentially the same instrument complement as well, except we are going to add a compact coronagraph, or a C-core instrument. It's yet another one of our sun-looking instruments in order to capture better data about where these coronal mass ejections and solar flares are headed. So we're really excited about that fourth launch. This will become GOES-19 when it launches. And then GeoXO is our future constellation. This is going to be launching in the 2030s. There's the major difference between the current constellation and the GeoXO is we're going to add a satellite. We're going to add a geocentral. And on that central satellite, we're going to place a hyperspectral infrared sounder. and an atmospheric composition instrument to measure air quality. And then on the east and west, we'll once again have an imager and a lightning mapper, and we're going to add a new instrument known as an ocean color instrument for measuring ocean color and to keep track of things like harmful algal blooms over the ocean. So that really wraps things up. I wanted to leave at least a few minutes for questions and answers, so I'll stop there and pass it over to Bill.
All right, thanks so much, Dan. That was an excellent presentation. It's really great to see the vast amount of useful information GOES-18 provides us, just not just environmentally, but also in space. I want to remind everyone that please, if you're virtual, please submit your questions to the Q&A. And if you want to submit a question here in the room, please walk up to the mic right there. Plenty of time for questions. So Dan's here. Dan's a great resource to answer questions about the GOES series. So now's your chance. So to start, I get to go first, Steve. Really, scientists and engineers did an excellent job preparing GOES-18 ABI imagery for operational use in an unprecedented amount of time. I still can't believe it's only been 5 months since GOES-18 launched and operational users are already using the data. Dan, do you anticipate instrument checkout in the future, particularly for new technologies such as maybe when GeoXO launches? Do you anticipate maybe more rapid checkouts in the future, such as this one?
Well, I'll start off by saying for GOES-U, that's sort of our next launch in just a couple of years. And, assuming everything goes well with all the instruments, which, it did in this case, I think we can easily do a fairly quick checkout. I don't know. I don't want to put a number on it, but, something on the order of 9 months I think is very feasible. In the future, I can't speak for sure for GeoXO, but I'll say, generally when you switch to a brand new set of instruments and a new spacecraft, it does take a little bit longer. So I think GOES-16, when we first launched it, it was a new set of instruments completely. It took about a year to go through the full checkout. So it's possible that's what will happen with GeoXO too. We'll have to wait and see. But generally, the more practice we get, the more reuse of technology that we're used to, the quicker it goes.
Thanks, Dan. Steve, do you have a question? Do you want to walk to the mic? And I'll do a quick question from online while Steve's gotten to the mic and turning it on. Dan, how does GOES data get merged with the numerical models?
Yes, that's a really good question. It's something I probably should have gone into detail about. So there's a few ways that GOES data is used with the models. I'll say the most fundamental way is something called our derived motion winds. And what that means is we use the ABI to track clouds with time. That's really the advantage of being in geostationary, is you can watch clouds move. And you can track them and you can assign a motion vector to them. So how fast is the cloud moving and in what direction? And then the final piece of information is the height. We use the cloud information, cloud top height retrievals in order to tell us where it is vertically. So that'll tell us, say, just for example, the winds are out of the west at 500 millibars blowing at 50 knots. That's just an example. And then we take that information and we feed it into the models through data assimilation. That's one way. Another way is the radiances themselves are assimilated into the model at some of the various spectral channels. And then the third way, and this is probably not even all, but a third one that I'll mention is we use the data to track hurricanes and get a heading. We get sort of a center location as well as an intensity and a direction and speed also. And that information is used to help initialize hurricane models themselves. It sort of gives them a really good first guess or first boundary condition, I guess, on which direction the storms are headed. So these are all sort of different ways that the data gets into the models.
Thanks, Dan. We have a question in the room from Steve Miller.
Hey,
Steve.
Dan. Nice presentation. And I had a question about the plans for the spares. Of course, you have a lot of great information content when you have multiple views. And things like cloud top height from parallax, and also things like aerosol scattering phase function from multiple views have been shown to be really beneficial. When you move GOES-17 to the spare location, and knock on wood, come 2024, everything is still working when you launch the next GOES, will there be 2 spares at 105? And if so, can one of them be turned on for the sorts of things I just mentioned?
Yeah, so I'll answer the first part of your question first. And the answer is, yeah, I mean, as of now, the plan is to put GOES-U into storage after checkout. And then we'll have 2 backups, which of course is great. I know eventually these satellites aren't going to last forever. So we expect the GOES East is the most likely to be the need replacing next. And at that time, I think the plan, I don't know how many years that'll be, hopefully a number of years from now, sometime in the late 2020s, we would move the GOES-19, which, GOES-U will become GOES-19 over to that position to take over for GOES East. But yeah, we will have 2 spares for some number of years until one of them is needed to replace it. To answer your second question, the short answer is we can't operate all 3 satellites all the time. And it's basically due to, I guess, it stresses the staffing needs and the processing equipment and everything on the ground. As in, the more satellites you have collecting data, the more people it takes to do that. And we can do that during checkout. They sort of have special staffing plan to do these checkout routines, but we can't always have 3 satellites collecting data at all times. It's just a little bit too much of a stress on the staff from NOAA and NESDIS. However, we will be, like right now, and during the brief checkout we had in the center location with GOES-18, we did collect some data that can be used by the research community to do some of the things that you were talking about, but it's just not something that's going to be 24/7, 365.
Jammer, we'll do a question online and then get to you. Dan, real quick, can you touch on the work being done for the development of automated wildfire detection algorithms?
Yeah, so I'm not the greatest person to answer that question. I will say that we have some operational wildfire detection algorithms now, and on both the GOES-R side and on the JPSS VIR side. There are a number of efforts underway, including by Dr. Mike Pavlonis, who is probably somewhere there in Madison. I don't know if he's in the room, doing some really innovative work on using machine learning to do some fire detection. And I don't want to speak because I think a lot of that work is just underway right now. So if that, maybe Mike, if you're around, you can take a stab at that one, or whoever asked that question, send an email to Mike Pavlonis and he can probably give you an update on that.
Thanks, Dan. Question in the room from Jammer. Can you flick the switch up towards you?
How's that? Okay. Hi, Dan. This is Jammer. We weren't able to get a sounder on the GOES-R series, but we did have an advanced ABI. And I guess we've been able to extract those kind of data from the ABI. In your opinion, did we lose any capability by not having a sounder separately?
Yeah, I think that's an easy one, Jammer. The answer is yes. The hyperspectral sounder, the original one that was planned was called the HESS. And the whole idea with hyperspectral means we collect data at a lot of different spectral bands. And what that allows us to do is increase the vertical fidelity with which we can extract temperature and water vapor information from the atmosphere. And with the ABI, we only have, say, 2 or 3, 4 at most vertical pieces of information due to the lack of spectral bands. But with a hyperspectral infrared sounder, we have a couple thousand at least. And that allows us to it doesn't give us 1,000 pieces of vertical information, but it gives us more than 3 or 4. I don't know the exact number, maybe on the order of 8 or 9 or 10 pieces of vertical information. And that really is critical for the models and for other things of being able to highlight where the moisture is, where the temperature inversions are and things like that. So we're really excited about the GeoXO era of getting that sounder launched.
Yeah, and I don't blame you for being excited. I'm a meteorologist. I've been looking forward to seeing a hyperspectral on US satellites for a while. I listen to a lot of satellite book clubs from the Tower S people, and it seems like the forecasters seem to be pretty satisfied with the data coming off GOES-R. Is it just because we don't know how good we can have it without the hyperspectral? Well, I mean,
satisfied is a relative term, I guess. I mean, they're happy with the data that they're getting now, but I think that if we give them even better data, certainly more information about temperature and water vapor in the vertical, that absolutely will be a great help for them. both from the numerical modeling standpoint as well as the nowcasting standpoint. Forecasters, don't have to rely on the models to give a really nice analysis of Cape, for example. They can get these approximately hourly updates or more from the sounder and be able to track that with time.
Right. Us meteorologists never have enough data. Thank you.
Thanks, Jammer.
Thanks. Related to a question online, Dan, can you touch briefly on the geostationary orbit, the orbit that the GOES satellites are in, and what area it's viewing and how it's viewing?
Yeah, I really should have mentioned that at the beginning. It's kind of the fundamental idea behind GOES. But basically, the idea is if you take really anything and put it at of a certain mass and put it at an altitude, a certain altitude away, it will orbit at the same rate that the Earth spins. And so it's able to, if we put it over the equator, it's able to orbit at the same rate that the Earth spins and take a picture every minute, every 5 minutes, every 10 minutes, and collect data that way. And what that allows us to do is make animations or a series of these images. I sort of think of it as a time lapse from space, is we're taking a constant, frequent pictures, putting those together and making a loop. A lot of those animations I showed, that's all it really is a time lapse from space at various spectral bands. I think, did that answer the question, Bill? I may have missed part of it.
Yeah, it did. Yeah,
Okay.
You got it. Can you just touch on, again, there's a couple questions on basically the GOES series. We have GOES-16 up there, GOES-17, now GOES-18 launched. Can you talk about GOES-18 replacing GOES-17 here pretty soon, and then what will happen with GOES-U when it launches?
Yeah, I know it's complicated, so it's a good thing to repeat again here. So basically what's happening is we decided, due to the loop heat pipe degradation that we see seasonally with GOES-17 ABI, to go ahead, since we launched GOES-18, it's very functioning satellite, go ahead and replace it as soon as possible. So we did an expedited checkout from the center of the country, then we moved it out to the west location. So right now it's sitting side by side with GOES-17 at about approximately 137 west to finish the checkout here over the next 6 months or so. And then in January, we're going to have it permanently replace GOES-17 as the operation of GOES West. At that time, GOES-17 will be moved over to the 105 west, which is roughly the longitude of Colorado over the equator, to go into storage as the backup. And then GOES-U, when it's launched in a couple of years, after its checkout, it will go into storage as well until it's needed as a replacement for either GOES East or GOES West.
That answers it, Dan. Thank you.
Yeah.
Switching gears a little bit, Dan, does NOAA have funding opportunities for scientists at relatively small universities doing science with GOES-R data products?
Yeah, occasionally there are data calls that come out from NOAA, and really not just NOAA. Look for things from NASA ROSES, and a lot of our partners as well have proposal calls that come out. It's not something that happens necessarily every multi times a year or even every year. Something that happens every few years, and it is based on funding availability. So keep an eye out for these types of funding calls. I don't think we have anything imminently coming out, but maybe next year, perhaps something associated with a satellite proving ground, you may see some calls coming out.
Great, thanks, Dan. Can you talk about the where users can access GOES imagery, such as GOES-18 online, and also not just imagery, but GLM data?
Sure. So there's a number of online resources available. The one from NOAA NESDIS is if you just do a Google search for something like STAR GOES-16, it's from the NESDIS STAR group. That's one place to get both GLM and ABI imagery. Some other popular websites are run by our cooperative institutes. The one at CIRA is called the CIRA Slider. And if you just Google CIRA Slider, you can find that. The one at University of Wisconsin is called the Real Earth. If you just Google probably Wisconsin Real Earth or something along those lines, it'll come up. So I believe all of these do have GLM options in addition to ABI. If you look around in the menus, you can find it.
Can you talk about, Dan, in terms of monitoring solar activity, that the GOES instruments are constantly monitoring solar activity, but leading up to the solar maxima in 2025?
Sure, yeah. So our instruments are looking at the sun. Some of them are collecting data from the sun itself, and some of them are collecting particle measurements of sort of the things that are, you can think of it as blowing by in the solar wind, blowing by the satellite. And as we approach that solar maximum in 2025, things like solar storms, solar flares, coronal mass ejections, they increase in frequency and sometimes intensity. So we're able to see them ahead of time. In some cases, we're able to, I shouldn't say we, I should say the Space Weather Prediction Center is really who it is, and NOAA National Weather Service. They're able to calculate the trajectory of the solar flares, predict when they're coming, and then provide warnings for people on Earth.
Any other questions in the room? Another question online, Dan, can you talk about what the next big thing is in satellite technology? This person would consider the Lightning Mapper to be one of those big changes with the latest suite. What's on your wish list, or what's coming in the 2030s?
Ooh, yeah, I mean, it's hard to say what would be the big thing. I know we've already mentioned GeoXO. From the NOAA side, I will mention, we're excited about all of those instruments to have atmospheric composition, to be able to do air quality from geostationary orbit, as well as ocean color, and then that hyperspectral sounder, which we've already talked about. Some of our colleagues in NASA are very involved with something called the TEMPO mission, which is going to be launching, I believe, in 2023. It is a research mission as opposed to an operational mission, but it is another one for measuring air quality. So I'm actually really excited to check out that data from TEMPO, because it might be a precursor to what we might see from the future GeoXO atmospheric composition instrument.
Okay, a few more real quick. Can you just touch on the spatial resolution of the GOES-18 imager?
So yeah, the GOES-18 imager has the same spatial resolution as the GOES-16 and 17 imager. And to be specific, at nadir, that means directly below the satellite. In the infrared bands, it's 2 kilometer by 2 kilometer pixel size. And some of the near infrared, it's 1 kilometer. And in the 0.64 visible band, which is sort of our highest resolution visible band, it's 500 meters on each side of the pixel. As you move away from nadir and go up to, say, looking at the US, the pixel gets a little bit bigger than that, but roughly, we call it 2 kilometer, 1 kilometer, and 500 meter resolution.
Last chance. All right, well, Dan, great presentation. I think that was a great Q&A session. Answered a lot of questions, and we got through all the online ones. And another round of applause for Dan.
I should say, I really wish I could be there in person with you guys in Madison. I wasn't able to come this year, but hopefully next time I'll be there for sure.
Thanks, Dan.
Thanks a lot, Bill. Great job with the moderating.
Thank you. Have a great rest of your day, everyone.
All right, everybody. Thank you very much. Fantastic. Dan and Bill, thank you for everything. I think that's all the time that we have available for us today. Just so you know, we will make this video available to Weatherband members at amsweatherband.org and at ametsoc.org. If you have further questions, or if you want to talk about the webinar, members are welcome to discuss on the Weatherband Community Forum. So thank you for joining us today. Take care, everybody, and have a good one. Bye.